All right, we're on part B of sinusoidal function transformations. This is going to be our last section on being able to translate sine and cosine graphs. Okay. So just making sure we understand the role of each value and that we're comfortable with it. Okay. So up first, there we go. You want to consider how evenly spaced the 5 key points are, right? That's how it's kind of helping us, right? Helping us understand that we're finding our halfway point, then our smaller halfway point, then our larger halfway point, right? So we're finding our halfway points, and that's helping us figure out those values. So we can find the endpoints of the first cycle of a trigonometric function in 2 ways. So what we've been doing is figuring out where it begins, and then adding where it begins to your period, right? So we find our C value first. And then we've been doing C plus 2 pi over the absolute value of your B, right? That's what you are doing on assignment A, correct? Okay. The second method is your C value. And depending on the shift, just being at 2 pi over B. Okay, this works typically if your C value is 0, right? Like if no change is taking place, and you're starting at the origin. Part B, today's. I did.
Wait, so how do you know whenever to use method 1 and 2?
It doesn't matter. Honestly, just stick to A.
Be different.
Well, method 2 is mainly when you're at the origin. So like there's your C equals 0. I would assume is how I would think about it. Yeah. So if C equals 0, then you know that you're only looking at the phase shift to know where it ends. Does that make sense? Your period to know where it ends. So up first with number 7, it says you have y equals 2 cosine 2 times x plus 3 pi over 2. Graph the function. Okay, so we're going to describe what took place. So our amplitude is what? 2. We have an amplitude of 2. Our period equals what? B equals 2 pi over B. And what's our B? Which leaves us with what? Pi. And our phase shift is, and it's x's are liars, so negative 3 pi over 2, which means we moved to the left, right? We went left, so we shifted left. So identifying that, and then from there, identifying your halfway points. So I personally tend to do it before I graph. So I know that it's still going to be a positive cosine. So positive cosine tells me I'm going to start with a max, then I'm going to have an x, then I'm going to have a min, then I'm going to have an x, and then I'm going to have a max. To start, my max starts at where now? Negative 3 pi over 2. And my final max is going to be pi units later, right? So if I have 3 pi over 2, what's 3 pi over 2 plus 1 pi? We get what? Negative pi over 2. Because that's negative 3 pi plus 2 pi over 2, which gives us negative 1 pi over 2. And now I have to find the halfway point. Sometimes it's easier to just count it out once you're knowing where you're at. My amp tells me how high I'm going to go. So at my max value, I'm going to be at 2. And then both max values are at 2. My halfway point is going to be at negative pi over 2. So I know that my minimum is going to be at negative pi over 2, which is going to be all the way down here at negative 2. And my x-axis are going to be halfway between. So I'm going to be here and here. What are those values halfway between? That gives me negative 5 pi over 4. Isn't it 4s? 1, 2, 3, 4. Yeah. My period isn't pi. My period is pi length long. So it takes a whole pi for me to make the cycle.
That's not two.
So what we did here was we did our phase. So we did our phase plus our period to create equals one cycle. Does that make sense? And then the pattern would continue. So I can continue the pattern all the way through, back down. And I'm going to go down to -2, come up. I'm going to go up to -2, go down. Pew, pew, doom, doom, pew, pew, doom, 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 doom. So now I've created a full cycle. Well, a full multiple cycles, actually. Pretend that I've gone through every single point. Use your imagination.
Oh, that's what I meant.
I did good? Thanks. I'll take it. Okay. So when you look at here, how many full cosine cycles do I have? 3. We have 1 positive cosine cycle, 2 positive cosine cycle, and 3. I have 3 full cycles within the window of view. 1 cup, 2 cup, 3 cup. Y'all see my cups? Okay. Are we feeling more confident in doing this? Okay. The other thing that I want to make sure is that you're able to describe the transformations in words. What is taking place based on the given function. So there are here on example number 8, we have 1 effect, 2 effects, 3 effects, and 4 effects. And we're going to need to describe what each one is doing. So I like to do it from left to right. So from left to right, what is taking place? Perfect. First thing we have is a reflection over the x-axis. Okay. Next, we have the 2. What is the 2 telling us? Our amp. So we have a vertical dilation. By, I think I need to write a factor of 2. By 2. Of 2. By 2. Okay. Next, what does the 3 tell us? We have a horizontal dilation, which affects what? Horizontal dilation by 1/3, which means that our period now is 2 pi over 3. I meant to write amp equals 2. And then the last thing tells us, it's called our phase shift. There you go. And which way did we shift? We did not go left. We went right. X's are liars. Oh, right. Phase shift right 2 pi. So therefore, one cycle would start at 2 pi and continue where? Plus what? Plus 2 pi over 3. So we're start. Oh, I don't have enough room to do that. So we're going to subtract. We got to go backwards. Can I do that one? I cannot. Okay. This is an example of when you cannot go to the right, you can actually go backwards. 2 pi over 3. So my graph is going to go a little backwards for me because I can't do it any other way. So I'm going to start at 2 pi. At 2 pi, that's for we're a sine graph. So we start at as an intercept, right? So we're going to be an intercept. After the intercept, you literally are going to work it backwards, okay? So think about it. not backwards. You're going to literally just follow everything else. You're just going to figure out where am I going the other way. So 2 pi minus 2 pi over 3 equals. Did I hear someone say 4 pi over 3?
Yeah.
Oh, okay. I knew it. Good job, guys. Good job. Okay. So I have my beginning and my ending in place. And now I'm going to find my halfway. What's the halfway? 5 pi over 3. So now my intercept's in place. If I am a negative sign, what am I starting off as? Going down. So we have x, then min, then x, then max, then x. So we're going to have our... I can't go to the right of 2 pi, so we subtract it to start from the left of 2 pi. What do you mean?
Like, why can't you start the origin? Like, if you know your origin is going to be on 2 pi, 0.
Yeah. Remember how we said there's 2 ways of doing it? I'm showing you one, and then we'll do the other in a second. Easy killer. Easy killer. We're getting there. All right, so halfway, we are at amp of going down to -2, going up to +2, and okay. Because it's when we did our phase shift to the right, it shuffled to 2 pi. So our starting point using that, the first model, is at 2 pi. But we couldn't go to the right of 2 pi. We only could go to the left. So instead of adding, we ended up subtracting. So we could go to the left. All right, the other method. So remember how it says there's 2 ways of doing it? The c plus the 2 pi over b. I guess technically this would be plus or minus, depending on where it's located. And then just c value, and you just start, your period ends at your shift. So you would stay at the origin. So if that happens, you're going to be at the origin. And you're going to end how long your period is. So how long is it going to take us? 2 pi over 3. So we would end here at 2 pi over 3. Find your halfway. And then again, your minimum and your maximum. And then what's going to happen in between these two? Do they end up repeating? Is either method acceptable to complete the graph? Yes.
Which method is that? Because the first one was like on the
The first one was method option 1, where I have my c value and I do c plus or minus 2 pi over b. Okay. Do we understand why we went left though? Why I couldn't go plus?
Yeah.
Okay. How we feel? Oh,
Okay.
Can you describe transformations of a sine graph or cosine graph? Yes? Anyone's like, never mind, not doing it. Can't do it. Oh, well, you can. I believe in you. So suck it up, buttercup. Okay, here you go. You now have a graph with a midline. Do y'all want to do the midline together? You feel confident enough to do it by yourself?
Yeah.
I heard by yourself first. But I heard by yourself first. So let's see how far you can go by yourself. Okay. You needed to make sure that it expands all the way from 0 to 12. All right. So first up is our amp. So it says define your amplitude. Remember, your amplitude is the absolute value of your A value, right? So amp equals absolute value of -2, which makes it 2. Okay. Next is our period. Your period equals 2 pi over b. And what is our b? Pi over 3. And after we keep, change, flip, what are we left with? 6. Yes? Yep. Awesome. What about our midline? It's 3. It's at y equals 3. So this is now our new point of intersection, right? 2. Okay. So this is a negative cosine. So that means it starts off as a minimum, then x, then a max, then x, then a minimum. Where's my starting value? 0. And where do I end? At 6. And then what's the halfway? And then what's halfway between these two? And halfway between these two? 4.5. Okay. And then my min and my max. So what is going to be my minimum value? And what's going to be my max value? 2. Are we good? Okay. So we're going to go to 0, -2.
Wouldn't it be?
Wait, I thought you go to.
Wouldn't
Oh.
it be 1 then? Yeah, it wouldn't
I didn't do that. You saw nothing. You heard nothing. 3 minus 2.
1.
3 minus 2. 3 plus 2. 3 minus 2.
Okay.
There we go. You saw nothing. What are you talking about?
I was like 1.
1. And then we're where here? At 1.5. And then we're at 3. And we're going to go up to 5. And then we're at 4.5 and we're at 3. And then at 6, we're at 1. And if it wants me to go all the way to 12, I'm going to repeat this pattern all the way through. Does that make sense? So we're now at 7.5. And then we're at 9. And then we're at 11.5. Now I lied, 10.5. Because I can't math sometimes. And we're at 12. Did I make it all the way to 12? Now here comes the real test.
Okay. Oh, she's getting there.
Yeah, look at her. She did it. All right. Yes. All right. Now we're going to go backwards.
Take that. Oh, wait.
You're going to be just given the description and you have to create the function, the equation. Okay. We're going to go backwards. Okay. All right. So up first, it tells us that our amplitude is 3. Our period is 2 pi over 3. Our phase shift is pi over 3 right. And our vertical shift is none. What we're going to go through is identify our A, our B, our C, and our D. Got it? It would have to tell us that there's a reflection.
Okay.
Does it say anything out reflecting? No. So do we worry about it? No. So, yep. What is our A? We know A equals 3. Okay. How do we solve for our B? We're going to look at we don't have to do that. So your period is 2 pi divided by 3, right? So it's just going to be 3. So B equals. Yes. Phase shift. It's going to look like a negative, right? Okay. And then what about our D? It equals 0. Will I need to write it? No. Okay. Just remember, when you have period, all you're doing is doing 2 pi over B equals whatever they say. In this case, did I have to cross multiply or anything? No, it was very obvious what B had to be. Okay. All right. So our equation, y equals A sine B pi over 3. Geniuses. I knew you could do it. The B has to be separated. Yep. Good job, Ren. All right. You do cosine. Bracket and parentheses are interchangeable. Okay, y'all are doing cosine. Identify your A, your B, your C, and your D. All right, so let's see how we did. So for cosine, you have amplitude of pi, given that amplitude of 5, period of 4 pi, phase shift of pi over 3 left, and vertical shift 2 units down. So the first start off with, we know that our amplitude tells us that our A equals 5. Our period, we're going to find our B value. By finding your B value, remember it's your 2 pi
over b equals 4 pi. So you just need to solve for b. So when you solve for b, you end up with b equals 2 pi divided by 4 pi, which is 1/2. So we now know our b value equals 1/2. Our phase shift is left pi over 4, so it's going to be c equals, and it's going to be pi over 4 plus pi over 4. We write it in vertical 2 units now means that our d equals -2. So now we're going to put it all together, and we have y equals 5 cosine 1/2 times x plus pi over 4 minus 2. Okay? If you did that, then you did awesome and good job. Okay, so here it says write a sinusoidal equation. The fact that it says sinusoidal equation, that means it can be sine or cosine. So we're going to model both. It tells us our amplitude is 2.5. So we know A equals 2.5. I don't know how to make this just by itself. Okay, our A equals 2.5. It says that our period is pi. So we're going to find our B. So again, we know that if you just need to remember the quick math, that means 2 pi over b equals pi. So therefore, b equals 2 to make this a true statement. Okay. And then it says in 0.20. So we need to ensure that 0.20 is on our graph. Well, that's important because that's going to help us discover our shift. So we're going to let the 0.20, that's going to represent our B value, and that B value is going to help us find our C value. All right, so to begin with, we're going to find our sine function, and that's because in, I want to say, 3A.6, we discussed how, no, 3.3, we discussed how all sine functions can be written as cosine functions by adding pi over 2. So if I find the sine, then I'm just simply going to have to add pi over 2 to my C value and go from there. Okay, so we're going to set up with what we know. So we know that y equals 2.5 sine of 2 times x minus c. How do I know there's a c? Well, there has to be some kind of shift that allows 0.20 to be part of this. So we're going to figure out the c. What we also have to recall is basic solving. We're going to plug in what we know for x and for y. So we know x and y. So we're plugging in 0 equals 2.5 sine 2 minus c. Okay. Now, this 2.5 is important as our amplitude, but as far as the solving for c, I'm going to divide 2.5. So if I'm going to divide the 2.5, it's going to go away, right? It's going to 0 divided by 2.5 is 0. But what is important here is I have to think about what sine theta equals 0. So thoughts that I'm going to have, and for some reason I cannot get to my pen, so do it in different colors. So we're asking ourselves, sine theta equals 0. What does theta have to equal in order for sine theta to equal 0? So this is going back to our unit circle. Remember, on the unit circle, your sine value is represented by the y coordinate. So when you're thinking about on your unit circle, what theta with a y coordinate of 0 can I use? Well, theta can either equal 0 or theta can equal 180. Because at 0 and 180, that's when sine theta equals 0. Okay. So we're going to set our 2 times 2 minus c equal to 0. If you want to set it equal to 180, don't let me stop you. But be mindful it's in terms of pi. So instead of 180, you'd be setting it equal to pi. But we're going to set it equal to 0 because why do something harder? So I'm going to take 2 times 2 minus c instead of equal to 0, which is going to leave me with 2 minus c equals 0. So c equals 2. So now I have my c value. I have my a, I have my b, and I have my c to ensure that 2 comma 0 is on my graph, part of my function. So my equation is y equals 2.5 sine parentheses 2x minus 2, and that is my sine function. Okay, so there's my sine function. To find my cosine, I would really like to be able to write. Hold on. There we go. To change colors. So to find my cosine function, the reason why we say you're going to add pi over 2 is because the values of sine and cosine change. They're equivalent, or not equivalent, but the change in the shift is every 90 degrees, pi over 2, right? A way to think about that is if you are just looking at your quadrantals. So here I'm at 0 and I'm 1, 0. Here I'm at 90 and I'm at 0, 1. Notice on this time, we would be looking for when does cosine equal 0, right? So when does cosine equal 0? And cosine equals 0, my smallest value is 90, which is pi over 2. So all I'm doing is taking the value that I already have and adding pi over 2. So for this problem, it's c would equal, so if I was doing cosine to find my c, all I'm going to do is take the c value of my sine, which is 2, and I'm going to add pi over 2. So c equals 2 plus pi over 2. Right? And that's what my c value would be. That's my exact value. I mean, you combine it into one fraction if you wanted to, but I'm okay if you wrote the cosine c value like that. Now, what you could do to make it easier on yourself is you could go ahead and distribute if you wanted to as well and add on from there. So by distributing, you would distribute 2 to the x, 2 to the negative 2. So your sine is actually y equals 2.5 sine 2x minus 4. And that's what I'm adding onto. Okay, so we have y equals 2.5 cosine of 2x minus 4 plus pi over 2. And that would be my cosine. Now, please note that there are other possible options to get per sine and cosine that will satisfy the given restrictions. These are the two options using the smallest angles to calculate. Okay. Lastly is a calculator problem. And it says, find the equation for each graph, state the amplitude, period, phase shift, midline, verify your equation with a graphing utility, state the maximum and minimum points in one period, and the points of inflection. Okay. So up first, we're going to first decide what are we looking at graphically. So we are looking at a sine function, not just a sine function, but a negative sine function. So we know that we have a negative sine. I wrote sine. Huh. You saw nothing. A negative sine function. Okay, on this negative sine function, we're going to identify our midline. So finding our midline, remember it's the halfway point between your minimum and your maximum. So 1 plus 5 is 6. Half of 6 is 3. So my midline is here at y equals 3. Okay, so we found our midline. Next, we're gonna find our amplitude. Our amplitude is how far are our max and minimum from our midline. So our minimum and maximum are 2 units from our midline. So we know that our amp equals 2. Okay, we're going to find our, I just had a brain fart. What was the button? We're gonna find our beginning, our phase shift. So our phase shift is here at 0. So we are starting at 0. So that lets us know that this is our starting point. And then we're going to calculate how long it takes us to complete. So remember the pattern here that we have our intersect, then our minimum, then our intersect, then our max, then our intersect. The reason why I'm saying intersect is because they're no longer x-intercept, it's just an intersection with the midline, okay? So we've kind of broken down everything that we can tell from this graph, right? And it now wants us to state our amplitude and all that good stuff. So we know amplitude, absolute value of A equals 2. So, and then we're going to state our period. We can count it out, but just to be sure, we know that our period is 4 pi, which means to find our B, it's going to be 2 pi over B, which means that B equals 1/2. Our C equals 0. We don't start anywhere. And our D is our midline, and our midline is at 3. So we have our amp, we have our period, we have our phase shift, and we have our midline. Okay, and now we're going to create our equation. So we have y equals, and we know it's a negative sign, so that means our A value is -2 sine. Our B value is 1/2 x plus 30. And you can use graph to calculate. Okay, our maximum, it says to find your maximum points in one period. So our max point, if I come over here, is at 3 pi, 5. And our minimum point, our minimum is here at pi, 1. Okay, and then your POIs. So your POI for this period, our word is a change. So it's going to be our intercepts. Change concavity. So our POIs, our point of inflections, take place at x equal 0, 2 pi, and 4 pi. Okay. And there you go. And if you didn't trust your graph, you could always, your equation, you would graph it and analyze to verify all that you have. Okay. I would like for you guys to try this one on your own and check yourself, and then the answer we will talk about class on Monday. Have a great weekend. Do you need me any